All right, guys, we've multiplied, we divided fractions. Now we're going to add and subtract them, which means, you know what that means? It means an LCD. All right, add or subtract with a common denominator. If you have a common denominator already, it makes things so much easier because all you have to do is just look at this. If you have the same denominator both C's, you just add the numerators. Same thing with an algebraic fraction. If they already have the same denominator, the denominator stays the same, you just add the numerators together. That's all you do. Subtraction works exactly the same. If you have this algebraic one here, once you have the same denominator, you just subtract the numerators and you're good to go. So let's try a couple. These two right here already have the same denominator, so what I'm going to do is I'm going to go ahead and just add them. My denominator is going to stay the same. In this first one, 4x, I'm going to add the 7 and 3 and get 10, and I would be done, except for hopefully you realize that 2 goes into 10 and 4, so I'm going to make that 2 goes into 10 5 times, 2 goes into 4 2 times, 5 over 2x. The more tougher one here, I guess tougher, sorry about that. They already have the same denominator, it can't be that tough. Remember, denominator stays the same once you have found one. Don't try to add those together or subtract those. Just subtract your numerator, 2x minus 5. This time there's nothing to cancel. Remember, don't be the one that cancels those x's. They're not factors. You can only cancel factors, remember, from the other day. All right, what if you don't have the same denominator? Well, if you don't have the same denominator, basically, you've got to find them. And one way to find them, as this looks down here, is you can multiply the two denominators together. And here's the deal. Whenever you multiply, whenever you find your LCD, what I'm going to do is, like that has a denominator of C. My LCD is CD. You have to multiply the top by whatever the bottom needed to become that. That sounds complicated, but it's really not. This one was a D. It became CD, which means you had to multiply it by C, which means you multiply the numerator by C. So, and the same thing with subtraction. So you're going to hear me say this a lot as we go through this lesson is, look what this denominator needed. Now I'm going to multiply the numerator by that term, okay, as we go through. So let's just do a couple. That's the best way to do it. Is just look at how we work here. All right, let's just try one here. Find the least common multiple. Now, the least common multiple is the same thing as an LCD, except they're not fractions yet. All right, there's just two terms. Let's just practice. So what you need to do first always is factor if you can. So if I factor this first, I can take a 4 out, which gives me x squared minus 4, which is a difference of squares. So I can keep factoring. I can make that x plus 2, x minus 2. So there's the first term. The second one, I can take out a 6, which leaves x squared minus 4x plus 4. And I can factor that some more too. That's going to be x minus 2 squared, which is x minus 2, x minus 2. So when you find the LCD, here's the steps. First of all, look at your coefficients. Find the LCD or the LCM of your coefficients. The smallest thing that 6 and 4 both go into is 12. Then I'm going to look at all the other factors. You have to use every other factor. So I'm going to use an x plus 2 and an x minus 2. Right now, the last thing is this. When they have factors in common, like both these terms had x minus 2's, when they have factors in common, you use the biggest exponent on that factor. So that means on my x minus 2, I've got to put a square. Because if you think about it, x minus 2 does go into x minus 2 squared. All right, x minus 2 squared does not go into x minus 2, so you have to use the biggest exponent of what they have in common. Now, notice I did not add any exponents. I didn't make it x minus 2 cubed. Do not ever add any exponents when you are finding an LCM or LCD. Use what they gave you, but use the biggest exponent if it's something they have in common. Okay, let's try one here, a full addition problem. First thing I can do is find an LCD, so I'm going to factor my denominators if I can. I can't do anything with that one, but this one I can take out a 3x, and that leaves me with an x plus 1. Now watch what I do here. I'm going to make one big fraction, and I'm going to put my LCD down there. Start with your coefficients. 3 and 9 both go into 9. I have an x and an x squared. So they both have x's. Remember what we just talked about. Use the one with the bigger exponent. There's also an x plus 1, so I'm going to put an x plus 1. So the rule is pretty much like I just said a minute ago, you must use every factor, and if they share one in common, you got to use the biggest exponent of that factor. So here's what you do with your numerators. Look at what we have down here. Look at your denominator. What does it need to be that? Like, what is it missing to be 9x squared x plus 1? Well, it needs the x plus 1. So that means I need to multiply the numerator by x plus 1. Now if I do that, I get 7x plus 7. Okay, now I'm looking at this denominator. It has a 3x, has an x plus 1, so think about what it needs. Well, it already has the x plus 1, but it needs a 3 to become a 9. It needs one more x to become an x squared. So I'm going to multiply the x times 3x, and I would get 3x squared. So just to finish it up, I get 9x squared. That's a very crooked fraction bar. Oh, x plus 1. And my numerator is going to put it in right order. Put it greatest degree to least degree. 3x squared plus 7x plus 7. Now, you do need to look at your numerator, and if you can factor that, maybe factor it to see if anything cancels, see if you can simplify it at all. But that one doesn't. That's as far as you can go. So this right here would be your sum after you add. Okay, let's try subtraction. Same steps, just got a subtraction sign instead of addition sign. There's one hazard as we go through that I'll tell you about as we go, but pretty much the same. So start out by factoring your denominator. Take out a 2, that's an x minus 1. Minus sign is an important deal. Factor this denominator, you would get x minus 3, x minus 1. Okay, here we go. Find your LCD, which means all the factors. I have a 2, I've got an x minus 1, and an x minus 3. Notice that I did not put x minus 1 squared because there's no squared up there, okay? Remember, do not add exponents to anything. Use what they have in common, use the biggest exponent. So here's what I'm saying. What does this need? What does that denominator need to be the LCD? What needs an x minus 3? So I'm going to multiply that numerator times x minus 3. So I'm going to come down here. I'm going to do x plus 2 times x minus 3 in just a second. Minus is huge. I'm looking at this one. What does that denominator need? It just really needs a 2. So I'm going to multiply it by 2. Now, when there's a minus sign, here's what I would do. I'm going to go minus 2, put a little bracket or parentheses, doesn't matter, to protect your minus sign. Because that minus sign, people don't realize this, but a fraction bar is a grouping symbol. So the minus sign really goes for everything on top. So you must make sure you distribute that negative sign. And using a parentheses or a bracket will help you do that. So I've got some work ahead. I'm going to do FOIL on my first two, in my numerator, x squared minus 1x minus 6. I just did FOIL all together right there in one step. I'm going to distribute this negative 2, which gives me a positive 4x and a positive 2, and all that is over our LCD. Got stuff everywhere. Okay, now combine what you can. I've got an x squared, I got a negative x and a positive 4x, that's positive 3x, I got a negative 6 and a plus 2, that's negative 4, and I have this, 2 times x minus 1 times x minus 3. Now I'm just looking at my numerator, and it looks like it could factor, so I'm going to try to factor it. I know you're like, man, I thought we were done, and I did too. So I can factor that like x plus 4, x minus 1, and my denominator is still 2 times x minus 1, x minus 3. I think you can see what's about to happen. So I can simplify. The x minus 1's cancel. So my final difference or answer is x plus 4 over 2 times x minus 3. That would be a doozy right there. You may need to go back and watch that again. The steps aren't that bad. There's just a bunch of them. You just got to be really careful as you go through not to make silly mistakes anywhere. Okay, simplifying complex fraction. A complex fraction is basically when you have a fraction that contains a fraction, like a fraction in a fraction. There's two methods. There's a method 1, method 2. I'm going to be honest, I love method 2. But I'm going to show you both because maybe you like method 1 better. Method 1 says you simplify numerator and denominator by writing as a single fraction, then divide. Okay, that's one way. I like this one. Multiply the numerator and the denominator by the LCD. And the stuff's going to cancel. So I'm going to show you one of each before this video is over on the next two slides, and you pick which one you like best. Method 2 is better. Okay, so here we go. Method 1. 1 over p plus 1 over q. So you see we're talking about fraction and fractions. What I'm going to do is I'm going to go to the bottom down here, and I'm going to add these two fractions together. Well, my denominator is going to be pq. Okay, one of every factor. Now, so I'm looking at this one. What does the p need to become pq? Well, it needs a q, so I'm going to multiply the top by q. Q times 1 is q. Same thing here. What does q need to become pq? Well, it needs a p, so I'll do 1 times p. So I got, 1 times p is p. I don't want you to mistake that for a negative sign. It's not. Now, what I'm going to do now is, remember, fraction bar means divide. So I'm going to do 1 divided by q plus p over pq. And we did division yesterday. When you divide, you multiply by the reciprocal, q plus p, and you get this answer. You end up with PQ over Q plus P. Now that wasn't that bad at all, and I don't like that method per se that much, that often, but in that case it wasn't bad, mainly because there's just a 1 in my numerator. If I'd had a fraction up there too, it would have been quite a bit worse, or I've had more than like another fraction somewhere. That'd been a hard thing to do, but that time it worked out really great. So method 1 is good sometimes, and that was one of them. All right, last slide, method 2. Method 2 is I'm going to find the LCD of all the fractions in the fraction and multiply top and bottom by that. So I only have 2 denominators. I've got an x plus 4, and I've got an x. So my LCD is x plus 4. What I'm going to do is I'm going to multiply the whole top by that and the whole denominator by that. And that's legal because x over x plus 4, if I put the same thing on top of each other like I just did, if I write that fraction, that's really just 1. So technically I didn't change I'm not changing the value of the fraction, I'm just going to change what it looks like. So what happens here on the top, let's look at the top only. My x plus 4s would cancel. So what that would leave me with is a 5x in my numerator. In my denominator, I'm basically going to distribute this right here across. So if I do my first fraction, the x plus 4s would cancel. So that would leave 1 times x, which is x. On my second one, the x's would cancel. So that would leave me 2 times, I don't know why I changed colors there, 2 times x plus 4. So as I work that out, I'm going to get 5x over x plus 2x plus 8. I'm going to end up with 5x over 3x plus 8. And that's method 2. And again, don't be the one that cancels those x's, because they're not factors. Okay, so that's method 2. That's my favorite one. I'm just being honest with you on the way I know how to be. So that's quite a bit of stuff today. Hopefully it wasn't really, really bad. We'll work on this tomorrow. You'll get it. You'll be fine. I'll see you then.